So yesterday we did a little bit of a preview of this lesson. You know, we're going to be talking about shifting to the left and right and changing the period where we squish the sinusoid closer together and stretch it out more. You should already have in your notes back from lesson 47 the complete equation for a sinusoid, y equals c plus a sine p, x minus phi. We've been using the centerline and amplitude parts of that formula quite a bit already. Today we are going to talk about p is something that we call the period coefficient, and phi is going to be something that we call the phase angle. We know that it is a horizontal shift. We call it phase angle because when we're talking about sinusoid graphs, we know that the horizontal axis is either radians or degrees, but it's always angles. So we shift left or right to some different angle. So that's the reason for the terminology phase angle. It is just the horizontal shift. Don't worry about what I have up there at the top for the moment. We will come back to that in a few minutes. So if we are talking about shifts, the way we look at the graph and figure out how far it has shifted, if this were a positive cosine graph, if we had no shift and you were drawing a positive cosine graph, what would be your starting point on the y-axis? Max, min, or centerline? It would be a max. So if we're trying to figure out a phase angle for a plus cosine graph, since the normal starting point is a max, we want to find the closest max to the y-axis. What is the closest max? Can you see how many degrees that is for the closest maximum? How much, Ian? It is at the positive 45, so we would say that the phase angle is positive 45 degrees. What if I were doing a plus sine graph? Normally a positive sine graph looks like what as it crosses the y-axis? Max, min, centerline. Okay, centerline increasing or centerline decreasing? So normally that would be a centerline increasing. So now we are looking for the centerline increasing point closest to the y-axis. It can be to the left or to the right. So let's see, that's a centerline decreasing, so I'm not going to use this one here. Got this is centerline increasing. Is that the closest to the y-axis? Callum, where is? Negative 45 would be the closest one, so phi would be negative 45 degrees. I could do either of these likewise with a negative if I wanted a negative cosine graph. Negative cosine normally crosses the y-axis. At what kind of point? At a minimum. Where's your closest minimum to the y-axis on this one? So here are my two choices. Which one's closer to the y-axis? Everybody point, left or right? So the one over here to the left, yeah, that's fewer than 180 degrees away. And let's see, right smack between 180 and 90, that would be exactly halfway between them. So it would be negative 135 degrees. And I could do the same thing for negative sine. Kind of making sense? So that's what I had written up here at the top. If we were looking for sine, if it were a positive sine graph, that normally crosses the y-axis, centerline increasing. So I'm looking for the closest centerline increasing point, and that, however many degrees or radians that is going to be my phase angle. If I were doing a positive cosine normally crosses the y-axis at a max, so I'd look for the closest max to tell me what the phase angle is for that. And I illustrated the same kind of thing with trying to find if it were minus sine and cosine. So let's try to figure this out for this graph. Can I do this one with no shift? Does it cross the y-axis at a max, min, or centerline point? No, so I've got to do it with some sort of a shift. So this one, my directions say I'm going to do it both as a sine and as a cosine. So let's do, I don't know, let's do cosine first. And let's suppose that I wanted to do it as a plus cosine function. One thing I need to look for then, a plus cosine graph normally crosses the y-axis where? At a max. What's my closest max to the y-axis here? So phi would be 30 degrees. What is my center line for this graph? Okay, center line is 0. Is that going to change whether I think about it as sine or cosine? Nope, that's going to stay there. What's the max? The min? That's not going to change either. So what's the amplitude? So no matter how I write the equation, I need y equals 0 plus or minus for sine or cosine something or other. So if I do it with the 30 degrees, I would have y, switch back to the red, y equals 0 plus 4 cosine, other variable is x, minus whatever that angle is, minus 30 degrees. We've done enough other graphs that if we have x minus inside the parentheses, that's a shift to the right. Does this look to you like a cosine graph shifted to the right 30 degrees? So that one makes sense. What if we wanted to do this as a plus sine graph? Center line still 0? Amplitude still 4. A plus sine graph normally would cross the y-axis at what kind of point? Center line increasing or decreasing? Increasing. So this is a center line increasing. Nope, that's center line decreasing. That's center line decreasing. That's center line increasing. Which of those two is closer to the y-axis? The negative 60. So phi is going to be negative 60 degrees. So our equation is y equals centerline 0 plus 4 sine x minus the negative 60. So it becomes a plus 60 degrees. We've done enough graphs that we know x plus inside the parentheses is a shift which way? Horizontal which way, left or right? Left. Does this look like a sine graph shifted to the left 60 degrees? Okay, for good measure, let's do one more. Let's do minus sine. Minus sine graphs normally cross the y-axis at what kind of point? Center line decreasing. So here's a center line decreasing. Here's another one. Which one's closer to the y-axis? So phi is positive 120. So the equation becomes y equals center line 0. We're doing a minus sine graph, so minus 4 sine x minus 120 degrees. Minus means a shift to the right. Minus sine graph shifted to the right 120 degrees. And we could also do a minus cosine graph or equation for this. Every sinusoid will have 4. Every sinusoid has a plus sine, a minus sine, a plus cosine, a minus cosine equation. They are not always all 4 equally easy to find. Sometimes you will be writing down all 4, sometimes 2, sometimes just 1, depending on the directions. Questions so far? Let's do one more here, and then we will try to draw the graph. instead of just the equation. Max. -2, min. So centerline. Amplitude. Okay, this one we are supposed to do as a sine curve. So we're going to read those directions, not cosine. So if we do it as a plus sine graph, plus sign crosses the y-axis, center line increasing or decreasing? Increasing. So how many degrees for the closest one? So phi is going to be -90. My variable this time y and theta, so y equals center line -3. I'm doing a plus sine graph, so +1 sine theta minus -90 degrees. There's my equation. Could I do a minus sign for this one? And if I wanted to do minus sign normally crosses the center line where, Ryan? Decreasing or increasing? So center line decreasing. So I need the nearest center line decreasing to the y-axis. How many degrees? Everybody? So +90 degrees. So the equation needs to be y equals center line -3. This time we're doing a minus sign graph, so minus amplitude 1 sine theta minus 90 degrees. That's not too bad, right? Okay, let's talk about drawing the graphs if they give us the equations. When you have a phase shift, you're not going to cross the y-axis at your normal point, right? Because you've shifted it from there. So wait to draw the y-axis. I'm going to show you the easiest way to figure out how to do these. Easiest way, always start 3 horizontal dotted lines with a straight edge. So get those down in your notes. 3, and you can use your notebook lines on there. Pretend that they're dotted. Normally, and let's see, for this one, what is center line going to be? 0. What's the amplitude? So I'm going to have 0, 8, and -8. So, okay, on this one, I know that my center line is going to be my axis, so I could go ahead and draw it with a solid line if I really wanted to. And that variable is going to be theta. Normally, if I have a plus sign graph, normally it crosses the y-axis at what kind of point? Increasing. So center line increasing. So I'm going to put my first dot. I'm going to do some scratch work, not really right on my regular graph. So I'm going to put the 0 down here. And then I'm going to do my nice equally spaced tick marks here. And center line increasing means I'm going to go up and down like that. And more equally spaced tick marks back this way. And then I'm going to draw in my nice curve. And that's what my graph looks like, but I'm going to need to get some angles labeled and get that y-axis in there. I want to label my critical points, which are maxes, mins, and center lines. If I did not have a shift, and since this shift is degrees, I know I'm supposed to use degrees, not radians, for my labeling. If I did not have a shift, these critical points would be 0, 90, 180, 270, and 360, and -90, -180, -270, and -360. My equation has theta minus 30 degrees. So what is phi for this problem? It is positive 30 degrees. So phi is the opposite of what you see written there. Since phi is plus 30, I am going to do a plus 30 to each of these numbers that I wrote down for my scratch work. I'm going to do 0 plus 30, so this point is now really 30 degrees. I'm going to do 90 plus 30, so this one is really 120 degrees. 180 plus 30, and I have two 10 degrees. I'm also I could keep doing the plus 30s, but I'm also noticing these are all 90 apart. So I'm going to have 300, and I'm going to have 390, which is what I'd get if I'd done the plus 30s here also. If I take negative 90 plus 30, I'm not going to get negative 30. It's not just take the negatives of all of these on the other side. Negative 90 plus 30 is negative 60. Negative 60 and 30 are still 90 degrees apart, just like all of these over here. And then I would have negative 150, and I would have negative 240, and I would have negative 330. Now I've labeled my angles. This is scratch work, so I'm going to neatly just draw a line through that so that we know not to grade that that's not part of the real final answer. All that is left is the y-axis. Does it still belong right here? Why not? That's 30 degrees. It's supposed to go through 0 degrees. So can't go through negative 60. That's not 0. Should it go exactly halfway between negative 60 and positive 30? No, so we're just going to kind of eyeball it. It should be closer to the 30 than to the negative 60. And all that is left is that we need to label that as y, and there's our graph. And since those are a little bit weird to wrap our heads around, let's do another one where we draw the graph, but this time let's do radians. So everybody shout out, what is centerline? What is amplitude? What is phi? It is going to be positive pi over 2. So I'm going to have my three horizontal lines. The middle one is 0, the top one is 5, the bottom one is minus 5. Since I know one of them is 0, I know this middle one is the axis, so I can go ahead and make that a solid line. And this one is y and theta, so I will label that theta. I'm going to wait on y. A positive cosine graph normally starts where, everybody? At the max. So my first dot is going to be at the max. Do my equally spaced tick marks, center, min, center, max. Let's go the other way. Center, min, center, max. Draw the curve. Normally that was 0. This one says the shift is in radians, so that's how I know I need to use radians on my horizontal axis. Normally it's pi over 2, pi, 3 pi over 2, 2 pi, minus pi over 2, minus pi, minus 3 pi over 2, and minus 2 pi. Since phi is plus pi over 2, I need to add pi over 2 to each of these, so that I have pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2. If I take minus pi over 2 plus pi over 2, what do I get? And then minus pi over 2, minus pi, minus 3 pi over 2. So this one's going to be easy to add the vertical axis, because I know exactly where 0 is. It's right through that point, and label it y. Now take a look at that graph. That is 5 cosine theta minus pi over 2. What would it be as a sine graph? With no shift, it would be the sine graph. So the sine graph is the same as the cosine graph shifted pi over 2 for this problem. Okay, we ready to talk about period? We saw on the video clips yesterday that when we changed the notes, we started with middle C, and we had the sine wave. We went up to B, and it got squished closer together. It did not take as big of a distance to go through a complete cycle. We could go through more cycles in the same amount of time. Change the frequency, we changed the period. The period is how far is it between repetitions. So to find it on a graph, we want the distance between any two like points. So here they have said the period is the distance from one max to the next consecutive max. So negative 270 to positive 90, 270 on that side, 90 on this side. The period is 360 degrees. But if they had not labeled the maxes, we could have looked at two mins, because they're the same kind of point. We could have said we have a min at negative 90. We have another one at positive 270, 90 on that side, 270 on that side. They're 360 apart. We could have said centerline increasing, not this centerline, because that's just half of the cycle. That's the centerline decreasing. The next centerline increasing would be here. That much would also be 360. Or for that matter, we could have said centerline decreasing, negative 180 to positive 180, 180 on each side, put it together, a total of 360. So be nice to yourselves on these. Don't think you have to find maxes. If they aren't labeled, you don't have to figure out the degrees or radians for them. If you can find two other points that are the same kind of points, just not maxes. So far, so good? Okay, let me show you some pictures here with some different periods. So if we had the regular sine function, we know that it would have had a max at 90 and a center line there and a min at 270. We know that what I just drew would be the regular y equals sine of theta. Y equals 2 sine theta. I only needed 180 degrees to do one cycle. I had two complete cycles in the space where I had just one before. If I do 4 sine theta, I've got one complete cycle and just 90 degrees, so 90 degrees is the period. If I do a smaller number, a half sine theta, 360 degrees is only half my period. I need 720 degrees to get the whole period. So the bigger the number before theta, the shorter the period is. The smaller the number in theta, in front of theta, the bigger the period is. They are inversely related. And I've basically got some of the same functions up here again. That's basically just a repeat just from the graphing calculator. You can just see all three of them drawn on one screen here. So adding to our formulas, in this equation where y is c plus a sine p of theta minus phi, this number that we have in front of the theta is not the period. The number in the equation is inversely proportional to the period. That's what's important to remember. Remember, inverse proportion, inverse variation, y equals k over x, p equals 360 over period. So you see how that's the inverse proportion pattern. And if we are using degrees, the number in the equation is 360 degrees over the period that we see on the graph. Or we could switch that around. The period is 360 degrees over the p that we see in the equation. If we're doing one with radians in the equation, or we're using radians on the graph, we don't want to use 360 degrees. We're not going to mix our units in the same problem. So we're going to say that the p in the equation is 2 pi radians over the period on the graph, or the period on the graph is 2 pi radians over p. So let's see if we can do a little bit of this with some equations and graphs. So for this one, what is my center line? What is my amplitude? Can I do this without a shift? Do I have a max, min, or center line on the y-axis? So let's be nice to ourselves and do it without a shift. So phi is 0. If we do it without a shift, am I doing plus or minus sine or cosine? Oh.
Doing
positive sign for our function. So far I know my equation has to be y equals centerline 0. I'm going to do plus sign, so plus amplitude is 6 sine something, which I don't know. My other variable is x minus phi, so x minus 0. And those zeros will let some things simplify. Okay, with degrees, my period is normally how much? 360 degrees. Is the period 360 degrees here? We've changed it. So we need to figure out how big the period is. So we want to be nice to ourselves again. Are there two maxes that they have labeled on this graph? Have they told us the degrees for any maxes? No, let's try something else. Have they told us the degrees for any mins? Have they told us the degrees for any center lines? Okay, can you give me two center lines increasing or two center line decreasing? Can you tell me how many degrees they've written beside those points? Can anybody tell me the degrees that are written on one center line increasing? So Jimmy, shout one out. Okay, negative 90 is a center line increasing. Can anybody tell me the degrees for another center line increasing? Evan? Okay, 0, and you're ahead of the other classes. The other classes all just set 180 degrees. And yes, it's a center line increasing. Are those consecutive? No, because all 4 of those are center line increasing. If I didn't know the 0 one, I could have used the first and last one and done some division to figure out how far between two consecutive ones. But much easier to say negative 90 and 0 are how far apart? 90. So the period on the graph, not the p for the equation, needs to be 90 degrees. Since it is in degrees, the p in the equation needs to be 360 divided by the period on the graph. So what is 360 divided by that 90 that we just figured out? 4. So I need to put a 4 in here where I had p. So my equation is y equals 6 sine 4x. That's not bad, right? That's not going to, I mean, the graphing's a little bit harder, but we get used to that with time. Okay, for this one, I'm having a little bit of trouble reading that. So what's my max?
-7.
What's my min?
-13.
How far apart are those? 6. So what does that mean my amplitude needs to be? And if my amplitude is 3, what is my center line that I'm having a little trouble reading here? Everybody good with that much? Okay, can I do this one without a shift? So raise your hand if you can tell me which function, plus or minus, sine or cosine, if I do no shift. Emma? Okay, so let's do this as a plus cosine, since we have a max right there on the y-axis. So far I know my equation needs to be y equals, center line is -10. I'm going to do positive cosine, so plus, amplitude is 3, cosine. P is what I don't know. My other variable is theta. I'm doing this without a shift, so phi is 0. So y is going to be -10 plus 3 cosine. I just need to figure out p times theta. So I'm going to look at the graph. You guys tell me, you guys raise your hand when you can tell me what the period is. You decide whether you want to use one max and the next max, one min and the next min, one center line decreasing and the next center line decreasing, or one center line increasing and the next center line increasing. I'm waiting for some more hands to go up. What do you think the period is? How far apart are two matching points on this graph? Everybody try to figure it out. Raise your hand if you can tell me how long you think the period is on the graph. I'm waiting for more hands to go up. Pick two maxes. Are they labeled? Pick two mins. Are they labeled? Pick two center lines increasing. Are they labeled? And which points did you use? Which maxes? Just tell me the radian measures of them. Okay, so Keith did 0 to pi and got that the period was equal to pi. Anybody use two different points and get pi? What'd you use, Ian? Okay, could have used minus pi over 2 and pi over 2, both mins. So we're convinced that the period is pi. Since this one is radians, p in the equation needs to be 2 pi radians over the period on the graph. So we have 2 pi over pi, which is, so we just put a 2 in here in front of the theta, and we've gotten that equation. That leaves graphing when we've had a period change. Okay, let's do just this one. I'm going to skip the other one in the interest of time since we're getting near the end of the period. So draw your 3 horizontal dotted lines with your straight edge. What is the center line? 1, so we can label that as 1. What is the amplitude? 3, so we can go 3 above, that's got to be 4. 3 below, that needs to be -2. Did I get that right?
Yes.
Okay, what is my shift? What is phi for this one?
0.
0. I'm doing it with no shift. I have a minus cosine graph, so where will that start? Okay, minimum. So my first point is at a minimum. I am not shifting it, am I? Since I know I'm not shifting it, I can go ahead and put my axis in. I know that is going to be 0. That is where the y-axis belongs. I can do my evenly spaced tick marks. I can do my points. And I can do the same thing on this side. And then I draw in my nice, pretty little graph. But I haven't labeled any of those critical points yet. I need to be able to label the maxes, mins, and center lines before I'm finished with my graph. I could go ahead and put my horizontal axis in. Should it go right here on the center line? No, it needs to go where 0 belongs. Is 0 exactly halfway between -2 and 1? No, need to put it, just kind of eyeball it closer to 1 than to the -2. Label it with the variable that matches the problem, x. My scratch work, normally this would have been 0. This is supposed to be radians, so normally this would have been 2 pi. Pi over 2, 3 pi over 2, minus pi over 2, minus pi, minus 3 pi over 2, and minus 2 pi. Except that's not what's going on here, is it? So that's not going to help me. What is the number in front of x for this problem? So p in the equation is 1/2. I need to get the period for my graph. The period for my graph, when it is radians, needs to be 2 pi over the number in the equation. So if I take 2 pi divided by 1/2, what do I have? 4 pi? So that means if this was 0, my next min needs to be at 4 pi. Is this max exactly halfway between two mins? What number is exactly halfway between 0 and 4 pi? Is this center line exactly halfway between this min and this max? So what number is exactly halfway between 0 and 2 pi? How far apart are all of my critical points going to be? So 0 plus pi, plus pi, plus pi, plus pi. Same thing going this way. Minus pi, minus 2 pi, minus 3 pi, and minus 4 pi. And I've got the axes labeled, max and min, so there's my graph. Any questions? Right, then let me get your homework sets for you guys and a small amount of work time. We knew it was a long